f of x, which is 10 cosine x, and they're giving us the interval 0 to pi over 2, and they want us to use n equals 4 subintervals or 4 rectangles and the right endpoint. So the area R4. This is what they want us to determine. And we know that the graph between 0 and pi over 2 of cosine is this. How do I know? Is because at 0 is 1 and at pi over 2 is 0. So I will divide this interval into 4 subintervals. I'm asked to use the rightmost point. For the rightmost point, this is this rectangle. For the rightmost point is this rectangle with the height here at the function. The next rectangle is the height here on the function, of course. And the last one is here, of course, on the function. So when I determine the area with using the rightmost point with 4 subintervals, first I have to determine this piece, which is equal. So, which is delta x, which is pi over 2 b minus a divided by 4. So then this will be pi over 8. So the area of the first rectangle will be pi over 8 times this height plus pi over 8 times this height plus pi over 8 times this height plus pi over 8 times 0. There is no height here. So basically I only have 3 subintervals, and obviously it will be an underestimated area because I'm missing these areas. Okay, so now pi over 2 divided by 2 is pi over 4. Pi over 4 divided by 2 is pi over 8. But now I need to determine this, which is pi over 4 plus pi over 8. So pi over 4 plus pi over 8, the least common denominator is 8, and this is a 2. So 3 pi over 8. 3 pi over 8. So therefore, when I multiply, I will multiply by f of pi over 8 plus f of pi over 4 plus f of 3 pi over 8. That's it. I will get my calculator. I'm just trying to keep it in place. And with a calculator, I will put in y equals, I will put 10 cosine x. That's my function. And better, you know what? Better, I would like to create a list. So I'm going to edit. First, I have to clear everything I have here. So I'm going to create in list L1, I will put pi over 8, pi over 4, and 3 pi over 8. So pi, oops, right here. Clear. So I want pi over 8. The next one is pi over 4. And the last one, 3 pi divided by 8. Just 3. In the second column, I highlight the top of the column, and I will enter pi over 8. And in parentheses, what is the function? 10 cosine of each entry that I have in the first column. So I'll put L1 and close another parenthesis. And now the calculator will give me each and every entry corresponding. This times this will be here. This times this will be the second entry in L2. And this times this will be the third entry in L2. All I want now is this sum. And I can go to stats and calculate. And I want list L2. And it will give us the sum. 7.907666, whatever. I don't know how many decimal digits they want. So I'm going to copy a few. So 7.90766. Let's see what they want. They want round your answer to 4 decimal places. So if they want 4 decimal places, then I will write 7.9077. And that's the final answer. Okay, let's look at something else in 5.1. The rest is pretty much the same. They want areas. They want you to use midpoint, leftmost point, rightmost point. Let's see what else is here. Let's look at the one which is number 5, if that's okay. Number 5, it's giving us a table. So from the same section, let's look at number 5. Still in 5.1. And I'm going to copy the table. They're giving us the time in hours. If you want to give me your table, I can use your table. If you want me to use what I see here in liters per hour. So oil leaked from a tank at a rate of R of T, liters per hour. The rate decreased as time passed, and values of the rate at 2-hour time intervals are shown in the table. So we have 0. Anyone wants me to do their problem, or it's this, the one I see here is good enough? Okay, well, I'm copying 8.7, 7.9, 6.7, 6.2, 5.6, and 5.3 respectively. Find lower and upper estimates for the total amount of oil leaked out. So when a function is decreasing, and we had that a minute ago, the rightmost point will be an underestimate. So that will be the lower. The leftmost point will be an overestimate. And that will be the upper. So only because the function is decreasing. So the rightmost point, so the area with the rightmost point will always be smaller than the area with the leftmost point for a decreasing function. Okay, so let's start with the area that is the rightmost point. We just did that. So the area, the rightmost point will be, so the interval between 0 and 2, and 2 and 4, and 4 and 6, and so on and so forth, is the delta x. Delta x is 2, so we have 2 in front. We are using the rightmost point, so I cannot use the 0. So I have to use the 7.9 plus 6.7 plus a 6.2 plus 5.6 and plus 5.3. And the area with the leftmost point will still be 2 as delta x, but it will be 8.7 plus 7.9 plus 6.7 plus 6.2 and plus 5.6. So now with the graphing calculator, I will just multiply because I can put them in. So 7.9 plus 6.7 plus 6.2 plus 5.6 plus 5.3, and I get a number, and the other one is 2 in parentheses, 8.7 plus 7.9 plus 6.7 plus 6.2 and plus 5.6. and I get 70.2. As expected, the upper 70.2 is greater than 63.4. So I will enter the lower as 63.4, and I will enter the higher or the upper as 70.2. Okay, let's continue with the next section. Let me give you a boost there, the definite integral. 5.2. Let's see. Would you like to look at a Riemann sum? Would you like to estimate using the midpoint rule? So for some integrals, for example, and we had an example like this before. The integral from 0 to 56 from sine the square root of x dx, we cannot find the antiderivative by hand. We can find a function whose derivative is sine the square root of x. So we can only approximate, and they are telling us to approximate with 4 subintervals. Is this something that you would like to look at, or you prefer something else?
Yeah, sure. This looks good.
Okay, very good. So we had a similar example sometime last week, I think it was. So first of all, I have to take the interval from 0 to 56 and divide it into 4 equal subintervals. So 56 divided by 2 is 28. 28 divided by 2 is 14. And then 28 plus 14 for this one is 42. So then I know that delta x is 14. And we are asked to use the midpoint rule. Let me go back to the problem. They're asking us to use the midpoint rule. So imagine the function is somewhere here. I don't care. This will be the midpoint. This will be the midpoint. This will be the midpoint. And this will be the midpoint. So I will find the area for this rectangle, the first one. I don't care. The function is somewhere here. As base times height plus base times height plus base times height plus base times height. So then the area midpoint 4 will be 14, and then f of this number. This half is 7. Then this half here is 14 plus 7, which is 21. And then plus 7, which is 35. And then plus 7, which is 49. So this is what we want. That would be the height. So f of 7 plus f of 21 plus f of 35 plus f of 49. Of course, I recommend the same method that we just did a minute ago. Go to lists, clear the lists, whatever you have. I will plug in, of course, 7, 21, 35, and 49. 7, 21, 35, and 49. And of course, for the top of the list, 14, and then I have sine, and the square root. And now the square root has to be taken from these numbers, which are listed in L1. Close the parenthesis. They may not want that, so okay. So I have 14 sine of the square root of list L1. So only when I highlight the top of the list. So then I press enter. I get all these numbers. And then I go back to what I just did. Oops, not that. This. one variable stats for list L2 and calculate, and it gives us the sum. And the sum happens to be negative 3 point, and how many, to 4 decimal places? Negative 3.0484 with 4 decimal places. So although we're not able to determine this area exactly under this under the function sine the square of x between 0 and 56, we cannot determine it exactly. But we can approximate it, and this should not be a bad approximation. It's not very accurate, but it's not a bad approximation. Maybe the second, the third digit, maybe the error. Okay, let's look at anything else from this section.